Today on Capechi's Corner, we're going to look at similar triangles theorems. The first theorem is Sas Similarity Theorem. It stands for side, angle, side. If an angle of one triangle is congruent to an angle of another triangle, and the sides including those angles are in proportion, then the triangles are similar. So if we look at our triangles given, I have a marking that I already have one angle congruent, B and E, and then I have my sides are in proportion, the ones that are including that angle. So if I look at 1 and 3 compared to 3 and 9, they are in proportion. So I can say triangle ABC is similar to triangle DEF. And just like in congruency, you have to be careful how you match up the letters. A matches up with D, B with E, and C with F. Our next theorem is SSS Similarity Theorem, which stands for side, side, side. If the sides of two triangles are in proportion, then the triangles are similar. So when I'm looking at my two triangles, again, I have to match things up. I'm going to go with my smallest sides, so 3 and 6 would match up, and then my next smallest, so 4 and 8, and then 10 and 5. So I have to make sure all three sides are in proportion. So I started looking at my proportion AB, so that's 10 over DE, which is 5. So it simplifies to 2 over 1. I'll move on, same thing. I have 6 for BC. EF is 3, which is also 2 over 1. And my last ratio there, AC, which is 8, over DF, which is 4. And all of those ratios are equal to 2 over 1. So I know that triangle ABC is similar to triangle DEF. In the next few problems, we're asked to name two similar triangles and identify the postulate or theorem that justifies your answer. So let's look at number 1. I have two triangles there that are connected. I don't have any angles or any parallel lines or anything, so I know I need to focus on the sides. So I need to see if these triangles are similar by SSS Similarity Theorem. So I'm going to match up the lowest value from each triangle, and then the middle value for the length, and then the highest value for the length to see if they're similar. What I did at the bottom here was I just redrew them. Sometimes it's easier visually if you redraw them and try to match things up. So my lowest value is 16 on my triangle ADC, and then to 24 on my triangle ABC. So I'm going to match that up, 16 to 24, which simplifies to 2/3. So if I want to show that these triangles are similar, my other two sides also have to have a ratio of 2/3. All right, let's look at our next set. So I have AD is 20, and that matches up with 30, which simplifies to 2/3. So far it looks good. And then my last set, I have 24 is to 36, which also simplifies to 2/3. So I can say that triangle ACD is similar to triangle BCA by the SSS Similarity Theorem. Okay, and taking a look at number 2, we have a big triangle, triangle ABC, and then we have the smaller triangle in there, a triangle EAF. So we need to figure out if these are similar. So I redrew them at the bottom, so I know that angle B is going to be 50. And angle A, now I know if this piece is 130, I know this has to be 50 as well because it's a straight angle. So I'm going to mark that down here. Now the one thing about this triangle is because one triangle is kind of set in the other one, they have A is congruent to A by reflexive. So I don't know what the measure of angle A is, but I do know that that appears in both triangles. So I can actually say that triangle ABC is similar to triangle AEF, and that's by angle-angle similarity postulate. In our last example for today, I have two triangles in which I have side measurements for 2. So there's no way for me to figure out if that third side is in proportion, so now I need to look at the angles. And I do know that there are vertical angles. Angle CAB is congruent to angle RAS because they're vertical. So now I can look at the sides to see if they're in proportion. And I do notice that this angle is included between the sides. So I'm going to first start with my smaller length. So I have 20 and 30. So I have 20 over 30. That simplifies to 2/3. And when I'm looking at 21, now again, remember my top triangle there, triangle ABC, was my numerator, so I need to be consistent. So I have 21 over 31.5, which I notice is simplifies to 2/3. So I can say that these triangles are congruent by side, angle, side similarity theorem. So let's identify the order. So I can say triangle ABC is similar to triangle ARS.